Hello, 5th grade mathematicians. We're going to be taking a look at entry task day 98. Let's read problem number 1. Enter the power of 10 that makes an expression equivalent to 9,000. 9 times blank. So, let's decompose 9,000. And we're thinking multiplication here. So we have 9,000, and one of the factors is 9, the other would be 1,000. However, the directions tell us to enter the power of 10. So 1,000 is considered a power of 10. We could also write that as 9 times 10 to the third power. Or you could write it as 9 times the product of 100 times 10. Those are powers of 10 as well. So typically, as I would look at this, I would just do the in exponential form. However, any of those methods would be acceptable. So I'm going to put 9 times, as we look at it, it says enter the power of 10. So I'm going to erase that, and I'm just going to put 10 to the third power. Okay, let's take a look at problem number 2. Which fraction model best represents 3 times 1/9? Now, whenever I see a multiplication problem, I also think in terms of 3 copies of 1/9. So when we have a multiple choice problem like this, oftentimes they try to see how careful you are. So I want to zoom in on our choices just a little bit here. And this first one, if we counted up all of the pieces in selection A, there are 8. So this is broken into eighths, so we know it cannot be, hear that? We know it cannot be A. Selection B is broken into ninths, but it only shows 1 copy of 1/9. So that leaves us with C and D, and we look at which one of those is broken into ninths. D is not, so it cannot be that. And C, if we were to confirm it, we have 1, 2, 3 out. 3 copies of 1/9, which is the same as 3/9. So C would be our choice. Moving on to problem number 3. Brian used 10 3/4 feet of plywood to make a climbing wall. He also used 6 4/8 feet to ramp to make a ramp for his skateboard. Which expression could be used to correctly determine the amount of plywood in feet Brian used altogether? Now, what's interesting about this one is sometimes in a word problem, when we use something up, we subtract it, but we have to pay attention to this phrase right here and the question that is asked. Determine the amount of plywood in feet Brian used altogether. So we see that we're going to be adding. So a couple of things here. First of all, we know that he first uses that amount for the climbing wall, 10 3/4, and we're going to add to it 6 4/8. So again, we have mixed numbers here, and we know that we need like units. So as we look at our selections, A, B, C, and D, we would ask ourselves, what is a common denominator between 4 and 8? Now, we see eighths and sixteenths used. Okay, and we also have to take into account our whole number. So we have 16 there. So A has 10 plus 6, B has 10 plus 6, C has 16, and D has 16. But I also know as I look at my fractions, I know that if I add those up, they're going to be greater than 1. So that is going to eliminate choices C and D, because I know it's going to be at least, my whole number is going to be at least 17. So let's go back to A and B. The question is then, so A uses the fractions 3/8 and B uses 4/8. Well, we see that 4/8 is used right here, but the question is 3/4 the same as 3/8? And the answer is no, it is not. So we know that it cannot be A. Now let's go back to B and make sure. What is 3/4? So, how do we make an equivalent fraction out of 3/4? Well, we know that if we multiply by 2 halves, we would get 6/8. So we see that the correct expression would be 10 plus 6 plus 6/8 plus 4/8. Again, I want to remind you all that there are different ways of looking at solutions, and you may have an alternative way of exploring this, and that is certainly acceptable. In fact, I challenge you, find as many ways as you can to solve these problems. Number 4, the rectangular prism shown is solid. Enter the volume in cubic centimeters of the rectangular prism. So remember, volume is 3-dimensional. We're going to have a length and a width and a height. And so we want to know how many cubes are held in this object. So let's count these up. So we have 1, 2, 3, 4, 5. And we have 1, 2, 3. In our next dimension, we have 1, 2, 3. 3 high. So we have 5 by 3 by 3, and remember that our measurement are centimeters. And because we have 3 dimensions, when we multiply this out, we're going to write in cubic centimeters, or centimeters cubed. So let's multiply 5 times 3 times 3. And does it matter which order we multiply these in? In other words, the answer to that obviously is no. We know we have multiplication. We can do any order. So as I look at this, I'm going to do 5 times 9. I would do 3 times 3 first, because that's just a basic fact. 5 times 9 is 45. And we're going to remember our measurements are centimeters cubed, or to the 3rd power. So let's go back and we will write our answer, 45 centimeters cubed, or cubic centimeters. Okay, let's look at the last problem in our entry task today. Enter the value of the product of 5 and 12 added to the quotient of 27 and 9. Or you can rephrase those again in different ways. So the first thing we know when we follow order of operations is we're going to solve what is in parentheses. So we're going to do 5 times 12. And when we do 5 times 12, we get 60. And then I'm going to find the quotient of 27 and 9, which is 3. And then I would find the sum. 60 plus 3 is 63. So remember, we want to follow the order of operations there, and when we do that, we do what is in parentheses first. So, if you have any questions, reach out to your teacher via Seesaw or attend their Zoom meetings throughout the week to have your questions answered. Have a great day.